everyone, welcome back to my channel. Today we're going to talk about RAG. Okay, so what's RAG? Okay, RAG is a Retrieval-Augmented Generation. That's what it means basically, Retrieval, Augmented, and Generation. And vector database. Okay, so the problem that RAG solves is basically when we say LLMs, okay, like GPT, Gemini, and Cloud, they have two major issues. Okay, they have, the first problem is missing knowledge or outdating information. Like LLMs are trained on data up to specific cutoff date, like January 2025 or 2023. Or if you ask about anything about this after that date, for example, who won the Oscar in 2025, the model either says I don't know or guesses incorrectly, which leads to the second problem. Okay, so I think already you have seen this response in some models. Okay, like for example, if you go to any model, okay, if you ask it a question, like it can only answer you like from its available knowledge up to the cutoff date. Okay, if it's 2024, then that's it, no more. Anything what happened after that year or anything, it's not going to it's going to say I don't know, right? Or it's going to guess incorrectly, which means it will hallucinate basically. The model invents answers when it doesn't know something. That's the issue, second problem of the LLMs. It gives confident, convincing answers that are completely wrong. You ask for a drug dosage, the LLM gives you a number, example 50 mg every 6 hours, but it has no source. This is dangerous in medicine, law, or finance. It doesn't give you an output source from where it got this details, right? So, or its hallucination happens because the model has no way of to say I don't know, always tries to generate something. Okay, so these are the two major issues of LLMs. Okay, we need to understand, and the question remains, why not just retrain the model? Retraining is extremely expensive, millions of dollars, and millions of dollars. It takes months. Okay, only big companies like OpenAI, Google, Anthropic can do it. Normal developers cannot retrain GPT-4, for example. So the question becomes, how can we get new knowledge how can we give new knowledge to LLM without retraining it? There are three solutions. The first is in context learning. It gives the model extra information inside the prompt like a cheat sheet. Okay, this is one way in context learning. This is small, simple, static information. And second is RAG. It gives the model access to a searchable library of documents, like PDF database or websites. This is best for large, consistently changing information. Or you can just fine tune it, retrain the model slightly with the new data to specialize the domains medicine with stable data. So in context learnings, you have, for example, you have a return policy. Okay, product can be returned within 60 days if unopened. Okay, user asks, can I return a blender of about 2 weeks ago? You inject the policy into the prompt before sending it to the LLM. The LLM reads the policy and questions then answers correctly. Okay, the problem is the prompt has limited size, context window. You cannot fit the whole library of the document. RAG, which is our main focus. Okay, this is the most important technology for AI agents. The core idea is, instead of storing knowledge inside the model, you give model access to the external documents like PDFs, database, websites. The model searches these documents first, then answers. A user question, retrieval plus searchable search document for relevant information. Augmentation, attach that information to the prompt. Step 2. Step 3, generation LLM answers using the retrieved information. Answer with the source. So yeah, this is the, we're just defining what are the steps here. The first one is retrieval. Retrieval means we just search the documents for relevant information. So in the examples that we're going to do, okay, to demonstrate the RAG, what we will do is basically we're just going to go to Google Drive here, okay, create some folder, for example, in Google Drive, and we're going to put our PDF or our data inside the Google and in this folder, right? So the LLM, our RAG application, first thing it's going to do is going to search for relevant information. That's what the first step, retrieval. Okay, it's going to search the documents for relevant information, right? Then augmentation, attach that information to the prompt. Okay, and then generation LLM answers using the retrieved information. Okay, answers with the source, no hallucination. That's the thing. So RAG solves both problems, missing knowledge. Like even if the model was trained in 2023, it can answer about 2025 by searching the external documents. Hallucination, the model answers from real source, not imaginations. It can even provide citations. When to use RAG? Information changes frequently, like policies, prices, and product. It's better to use RAG. You have a large knowledge base, thousands of PDF. You can use RAG. You need the real-time updates without retraining. You can use RAG. So fine-tuning, quick comparison. You do retrain models, but only slightly. Basically. So what we need to so the technical pipeline that we need to understand of RAG is that to build a real RAG, okay, you need these steps. First, we take the raw documents, whether it's PDF, text, audio, or image, or video. Then we extract raw text extraction. Okay, then chunking, split into smaller pieces. That's what we call by chunking. And embedding, convert each chunk into a vector, list of numbers. So then we have indexing. This stores vectors in a vector database. Okay, and query, user asks a question. Okay, query embedding converts question to vector. Similarity search, find closest vectors in database. Okay, and then retrieval, get original text from closest chunk. Augmentation, attach chunk to the user question. Generation. These are the few things that we need to focus on. Text extraction is the best. So as I said, the first thing we need is data, right? Raw documents. Then we extract the raw text, then chunk, put it into smaller pieces. This pipeline we have to remember. Then we embed it. Embedded means basically converting each chunk to a vector or a list of numbers. Okay, then index it. Indexing stores vector into a vector database. Okay, so then when the user asks a question, again it's going to be embedded, converts the question to the vector. Okay, then it does similarity search, the vector database. This is very important. This is what makes this whole thing very interesting. Similarity search finds the closest vector to the database. It doesn't have to be exact search or a keyword search. Okay, this is what makes it different from a normal database, or this is what makes RAG powerful. And retrieval, then get the original text of the closest chunk. Then augmentation, attach chunk to the user question, and LLM answers using this chunk. So these are the these are the steps that we have to memorize. Part 4, we have embeddings. The magic behind RAG. Embedding is a vector list of numbers. Okay, it represents a meaning of the piece of text. The embedding model is trained to put similar meaning closer together in vector space. We have CPU, processor, very close numbers. Important, embedding do not understand meanings like humans. They just map text to the position into high dimensional space where similar text is closer. Why this matters? Traditional search look for exact. Yeah, this is what we mean when we say embedding. This is what it does. It just converts this text to this kind of numbers. You got me? And like if you notice here, CPU 0.1, 0.2, 0.3, right? Processor 0.11. Yeah, 0.19, 0.51. CAD, we have this. Yeah, so traditional search looks for exact words or keyword search. Okay, vector search looks for similar meaning, semantic search. This is what's important. Example: search for sunset photo, vector DB character picture of sunset. Okay. It's a vector database, a database designed to store vectors, perform similarity test. Search. Find the closest vector to the query. Traditional database versus vector database. We have search type, exact match. Traditional DB. So we have vector database designed to store vector, perform similarity. Yeah, it's a database designed to store vectors and perform similarity search. That's what vector database is. Okay. It does similarity search. Okay, find the closest vector to the query. It doesn't have to be the exact word. That's the secret of secret power of vector database. Traditional database versus vector database. Traditional database, it uses SQL. It has exact match, follows exact match, like this one. But the vector database, like for example, find cat-like things, right? It doesn't have to be. Yeah, returns only rows with the exact keyword. This is a traditional database. Vector database, related concept like kitten, pair, all this stuff. And traditional database are slow for fuzzy searches. Vector database are fast with indexes. An example of vector DB power: you store the entire one with different reciters. You ask, find me sad voice recitation. Traditional database cannot do this. Convert sad voice to vector. Finds reciters whose voice vectors are close to sad. Returns showy. Like this is basically an example. Yeah, so the vector database power is you store the entire, for example, the Quran with different reciters like Shawi, Shari. You ask, find me a sad voice recitation. Traditional database cannot do this. Okay, vector database converts the sad voice to a vector. Okay, find the reciters whose voice vector are close to the sad. Returns Shawi, known for emotional recitation. So semantic search actually can read the meaning of of your question. Okay, that's the difference. It doesn't just give you the similar, it understands your meaning, the meaning of the word. Okay, best vector databases, we have Chroma. It's best for beginners, open source, runs on local machine, and it's best for learning route, prototyping, small project. Extremely easy to use, works with Python, LangChain, not for large production systems. Build your first RAG chatbot on your laptop. And we have also Pinecone, fully managed, cloud services, production SaaS, it's fast, scalable, billions of infrastructure, it's paid, not open source, enterprise chatbots, recommendation system. So this is the most used, the best for production. Weaviate is best for hyper search and only document for consistency. Milvus is big for big data. Redis is fast for real time. pgvector also we have. So yeah, so retrieval, this is the most critical part. Even if you have the best LLM, if your retrieval is bad, the answer will be bad. Retrieval, how will the system finds relevant information? The types of retrieval, we have semantic retrieval, vector search only, hybrid retrieval, vector plus keyword, metadata filtering only 2005, re-ranking, retrieve 20, re-rank another, garbage retrieval equals to garbage generation. The LLM is not the hardest part, the retrieval system is. Let the LLM search external knowledge first, then answer using what it found. The next step, yeah, so actually, yeah, yeah, so this is actually short theory about the concepts found in the yeah, so these are the key concepts. Right now we will do a small lab just to demonstrate using NA10, and yeah, yes, regarding the lab, I want to try something. Okay, I'm going to show you what I did just so you have an idea. We're not going to do it from scratch, we're just going to have a look at it. So we open NA10, click all, so it will open the workflow. So I want to show you something here, so we can just understand how it should be. Okay, just to understand the concept. Okay, so like I built something here. Okay, so but I want to use this one because this is actually more practical. Okay, so but I want to show you first the simple way so we can understand. So right now, okay, we have this one. Okay, this is basically a Google Drive trigger. Okay, this is a Google Drive trigger. Okay, it triggers when any change happens in a specific folder, like for example the Apple folder. Yeah, so this is what I want to say. Like here is saying trigger change involving specific folder, Apple. So if you go to Google Drive here, Google Drive, okay, you go to the folder Apple. I think this is the email that, no, it's not the email that I have, so it must be here. It is Google Drive. Okay, so basically what I did is I went to Google Drive, I opened Apple. Okay, I added this PDF files. Okay, So what it will do, okay, basically the idea is it's going to check if there are any change in this specific folder, like if there is any file created or something like that, like folder Apple, file created, watch for, file created, okay, then fetch. Yeah, so it will check if there is any new file added or something like this, and it's going to check, it's going to trigger. Okay, so once it's if there's any new file added, it's going to download this one. It's going to download the file. I'm using this one. You can find it, you can search from here and just download and just type Google Drive. Okay, and action, you have to choose download, basically. Download the file, this one. So here you can create a credential if you don't have a credential from Google Drive. I showed you how to do this in the previous videos. You have to go through it, and you can choose the operation, whether it's download for us, the ID. What I will choose here is I will put the ID, okay, of the input I receive from the trigger. Like if there is any new PDF or new file added on this Apple folder, it's going to come here, right? So I'm going to choose its ID, file by ID here. I'm going to check here the ID, I'm going to take it and put it here. Okay, you have to see like this. And then what happens is I'm going to use something called Pinecone vector. Okay, this is the most popular vector, like a way to create and store data as a vector database in online for production, basically. So Pinecone is very important. It helps you create vector database much simpler. The vector database built a knowledgeable AI. This is their website. Okay, so what you need to do is actually sign in. If you have to sign in, sign in. If you want to do it from here. Okay, and you can log in from here. You need to log in, but I don't want to use this account because my main account is actually here. So let me use this one, Pinecone. So this is Pinecone, basically. What you need to do is, from your side, first thing you need to go to the database indexes and create an index. Okay, I'm going to create an index just to show you how it is. Like you can name it anything, RAG, N8N, or whatever you want to name it. You can name it as you like. Okay, and then you have to choose the configuration, like the embedding model. Okay, for our case I'm going to use this one, text embedding small, but you can choose anyone. And here we have to choose the dimension. It's preferable to change it to 1536. Okay, so this is basically how much input it can handle at a time. That's what it means. So the more the better, actually. 1536. So other, we don't care, we just create an index here. Okay, and yeah, and next thing what we need to do is, once this is created, you have to go to API keys and create an API key here. Like type anything here and copy this one. This is the API key. Once you get the API key, you're going to create a new credential. You're going to paste it here and save. That's all we have to do. Here we have different operations. Okay, so we can say insert document. Okay, and choose from the list. It will give us the list of vector database that we created in Pinecone. Like I just created the RAG N8N, right? Here we can keep it 1. Okay, and our operation is to insert. We want to insert this the text or the details in this file to the vector database here, right, in our N8N. That's what we want to do, right? So but we cannot store it as just text. We have to embed it first, right? So if you remember what we talked about first, what it will extract the text, put it in chunks, different chunks, and then we're going to embed it, change it to numbers, like embed it, and then only we are going to store it to the vector database, right? So for this we have to get something called embedding OpenAI here. Okay, like I choose from here. If you remove this one, I will show you. Like you click this embedding, it will give you embedding document. You click it, it's going to give you this one basically. Okay, embedding models here. You can see the embedding models, right? We have embeddings OpenAI, you have Llama if you want to use open source, we have Kohara, Google, Gemini, all this stuff. These are the embedding models. Okay, but in our case we're using OpenAI. Okay, so you get this one and you create new credentials. Okay, so we're going to choose the dimension, put it same as 1536 as the one we have we'll put in Pinecone. Also the model, we're going to choose the same model that we choose in the Pinecone, right? It has to be same. And then we are going to add something called default data loader. Okay, you're going to search here data loader, data loader. Okay, and you're going to put it here. What it will do is basically take the data, okay, whether it's JSON or binary. Okay, then load all input data, then use text splitting. This will split the text. Okay, split every 1000 characters to 200 characters basically. It's going to split the text. Okay, then it's going to embed it and send it to the vector inside, put it inside the vector database. Okay, now let's see what happens when you execute the flow. It's going downloading, going to Pinecone vector. Yeah, so in my case there is some issue with this one. Okay, with the OpenAI, but it's supposed to do this, and then how it will be stored is basically like this. If you go here, if you refresh, you see now there is a data inside. Okay, you can see the data, the details here. Okay, so the idea here is that and embedding OpenAI. So once the data is stored, okay, so what we will do is basically the next step is going to be let me do it for you here. Pinecone, add Pinecone vector. No, remove this one. Let's just add Pinecone here. Pinecone vector store. But this time we're going to say retrieve documents for AI agent as tool, or retrieve a document for chain tool, because we are going to retrieve, right? Okay, we're going to retrieve from the but this is not the right way. 1 second. Pinecone here, we're supposed to choose retrieve, but it's supposed to be retrieve document chain as a, yeah, so we're supposed to choose this one, and I think we're supposed to also choose an AI agent. Actually, AI agent, we're supposed to add an AI agent here. AI agent, because we want to create a chatbot basically. Okay, so let me choose AI agent here, and yeah, triggered by chat. Yes, correct. So make an AI agent here, and chat model, let it be llama for our case, and yeah, keep it with Quinn, something like that, and no need for memory, but we're supposed to link this Pinecone vector with the AI agent. Pinecone vector with the AI agent. Actually, 1 second, let me stuff here. Pinecone. No, let me write it here. No, let me write it here so I can see what exactly is Pinecone doing. Okay, let me put this one. Yes, so now here also we're supposed to add an embedding. Actually, an embedding, let me say the OpenAI embedding. Okay, keep it like that, and also the tool here, we're supposed to link it with the here. It will be as a tool in the AI agent. Okay, and we can take one more line here from yeah, no need, just like this. So basically that's it. Okay, and data loader also is required, I think, because no, data loader is not required because we're not trying to insert. We're supposed to we're going to try to fetch data right from here, but I think it's required. Let me go ahead and see how I did it here. Yeah, 1 second, leave without sharing. Here we have yeah, no need for, because this is basically what we try to build. Okay, just we put it doesn't have to be exact, just we put an AI agent, we have a chat model, and we have we created the answer question with vector, Pinecone with chat model. So that's the whole point. The idea that we need to understand here is basically yeah, basically what we need to understand is this one. What we need to understand is what will happen here is when we add, we will have to add the chat here, right? When we type anything on this chat, okay, what the AI agent will do is basically is going to check, do a similarity search on the vector database stored in our Pinecone. Okay, and then but before it goes direct, it doesn't go directly to the does the search. It will have to be embedded, obviously, because it has to be embedded, changed to vectors, and it will search for a do a similarity search on the vector database. Okay, and then it's going to go to the AI agent, and it's going to display the output. Okay, basically that's what it does. It checks this part is only to check the vector database and to allow the customer or user to interact with the database, to chat with the database, and this part is actually to store the database. Okay, this is two different things. Also here we are supposed to have a chat model. So this is the idea. Okay, so now I will show you how it is done in a full production environment, so we can see what it does. Okay, just get the idea of how it is basically. So let's say we have here I just created the schedule trigger. Okay, this basically is triggered when it checks basically every minute, and it's triggered when there is a new data added on the file. It searches files and folders on the Google Drive, and when clicking execute, when you click this execute, it's going to get rows from the sheet basically. Okay, it's going to compare, it's going to take the data from the sheet. This is a sheet. We have a separate sheet to track what type of folders are already stored on the vector database and which are not. So this is just for us to track. Okay, so we don't add duplicate data on the vector database. Okay, so both, it will go to the merge here. Merge is just going to combine both this data and output, and it's going to put it in one. Okay, this is a code. It just checks basically. Okay, gets all incoming data in one flat array, separates drive file and sheet row by their structure, loops through incoming items, the text source, and extract already processed data, because we don't want to process again already processed. Filter only new files not in the sheet, right? And output only the new ones. Then append row to sheet. Okay, append the rows in sheet. Okay, that means once we start processing it, we're going to add it in the sheet, so we don't have, again later on when we want to process something else, we don't want to process this again. Okay, then we add edit field. Edit field we just add it so that we can add fields. Okay, like file name and file ID. Okay, so take the output, we put it here. Okay, file name and file ID, just to add these fields basically. And then I'm going to download the file. Okay, I'm going to download the file that I received from there. Okay, the file ID. Then I'm going to, this is one I added myself, but we don't have to use this one, you can just use it directly. So I use this one because I was thinking of adding another, there is a way to extract data from the PDF or images or all this, any kind of format. Like, there is a tool that can run on your PC using an API. You can use this one. This is just for APIs, but we don't have to use this one. Okay, we can connect it directly to here. The reason I use loop over items is like, so I wanted to store, like, let's say we received we have 4 or 5 documents in Google Drive. We don't want to put it all together in one the vector database. We want to separate it. We want to store it separately. Okay, that's why we use loop over item. So it will loop, like it will add one and then go send to the vector database. Same way that we use, and then once it's done, loop again and again. Okay, we use default data loader and embedding OpenAI, this as usual, and we have recursive character split. With chunk size we use 1000. So basically this is just to chunk or split the data before storing, right? Once the data is extracted, it's obviously, as discussed before, it's going to be split into chunks, and then only it's going to be embedded. Okay, then it will be stored to the vector database. Okay, these are the RAG pipeline. Okay, once it is like this, and we have a chat here. Okay, when the user types the chat, again we have edit field. Edit field is just if we want to combine more than one, like, or do some custom fields, like, you can use this command. AI agent, we just answer question. So basically this is how we can get, this is the idea of RAG basically. The most important concept that we need to put in our mind regarding RAG is actually this one. Okay, let me show you this pipeline. Okay, to build a RAG system, it doesn't have to be like using NA10. Forget NA10. It can be different tools like LangChain or other Python or whatever tool you use to build a RAG. The main concept that we need to catch is we need to understand is this one, the technical pipeline. It's always everywhere it's the same. Okay, we have raw documents. Okay, whether it's PDF, text, audio, or video, it doesn't matter. Okay, then we extract the text or extract raw text. Okay, and then we chunk it, split into smaller pieces. We call it chunks. Okay, this is the important part. Okay, and then once we chunk it, we have to embed it. Embedding is very important because it will convert each chunk into vector. Vector means list of numbers. Okay, list of 8 numbers. Then it will index. Index means store vector in the vector database. That's it. Okay, so once we store it, then we'll have the user will ask questions like query, right? And it's going to convert the question again to the vector using the same model. This is a very important concept we have to understand. It's converting it again after the user action. User asks a plain text, right? Question. It converts it to vector, and then it's going to do a similarity search. This also is very important. You have to keep in mind similarity search. Finds the closest vector in the database, and then gets the original text of the closest chunk. Okay, and then attach chunks to the user question. LLM answers using chunks. So these are the few things that you need to understand, and I hope it's clear, and thank you for watching. And I think this is enough for the RAG, and I hope it's clear, like the purpose of the concept is clear. Thank you for watching.